Hi everyone. We're going to finish up the last section of chapter 32 on plants. Okay, so we've talked about the need for transpiration, which is the process of opening up um, the stomata on the leaves so that the water could evaporate and that allows the water to travel up the plants. Now there's a careful problem, that needs to be carefully controlled because if you open up the stomata too long, you lose too much water, and if you lose more water than what you're soaking up in the roots, then your plant will wilt and die. And so there's this balance between making sure that you have enough water, the holes being open so that you can have transpiration to occur, but you don't want to have it happen too much. Um, and so you have these special cells called guard cells. And these are cells that kind of control the opening and closing of the stoma. And the way that it works, when the guard cells, which are kind of pictured here, when they're filled with water, they actually expand. And in expanding it makes it kind of bend because it's so full of water. And in doing that, it'll open up the hole and allow more water to leave. And this should make sense because if the plant is well hydrated, it can afford to have its stomata opened longer, and so the guard cells will be more filled with water because the overall plant is more healthy and more filled with water. The stomata will be open. When the stomata is open too long, the guard cells start to lose water and they shrink. So when the guard cells lose water and they shrink, they close, and it keeps the stomata closed. And so this is the way that the guard cells regulate how much when the stomata is open and closed. Generally, the stomata tends to be open during the day, and the reason why that is just thinking back to photosynthesis. You need to take in CO2 from the environment so that you can use the light when the light is still available to do photosynthesis and create sugars. But at night, when you don't have any more light, there's no need to take in CO2 because you can't really convert it. And so to minimize water loss, the stomata will be closed during the evening. There are three ways in which the guard cells know to open when the sun starts to come out. First of all, it's regulated by the light, so it has special light sensors that will help the stomata to know to open. It's also controlled by low levels of CO2. So when the CO2 gets too low, then the guard cells will start to open back up. And then also the plants actually have their own internal biological clock. So even if plants, they did an experiment that plants were all grown in a dark room, they still would open and close their stomata at regulated intervals. And of course, the last thing is that in general, even if it's daytime, if the plant is losing too much water, it will not really open up its stomata too much. The last thing that we're going to talk about with plants is nitrogen fixation. So this is the process of obtaining nitrogen from the environment. Plants, even though the air that we breathe in is 80% of nitrogen, the plants can't utilize it directly from the air, and so it's going to need the help of bacteria to convert that nitrogen into a form that it can use. And so what happens is we have some nitrogen fixing bacteria, and they can actually convert the nitrogen gas in the air into ammonia, which is this NH3 compound. In this process of converting N2 or nitrogen gas to NH3, ammonia is called nitrogen fixation. You have a different kind of bacteria that can also convert things into NH3. It's called ammonifying bacteria, and it will take decomposing material in the ground and convert it into NH3. So these are two different bacteria that will get us to ammonia. Ammonia picks up a proton from the soil and becomes NH4+, which is ammonium. And then we have something called nitrifying bacteria. And nitrifying bacteria will take NH4+ and convert it into NO3-, which is nitrate. And this is the main form that your roots of plants will use to incorporate NO3 nitrogen back into its system. So these are the three main bacteria: is nitrogen-fixing bacteria, ammonifying bacteria, and nitrifying bacteria. And all of them play a part in converting nitrogen in an unusable form into a usable form for the plants. And usually it is only able to absorb mostly nitrates. And so this right here is a more zoomed in picture if you guys want to take a look at this and copy this down in your notes. Okay, thank you guys so much for watching. I'll see you guys in class. Bye.